Hey everybody, in this video we are going to be covering the final exam study guide, and I'm going to make 4 separate videos for each of the modules. So in this video we're going to be talking about the questions that are from module 4 on the study guide, and then in the next 3 videos I'll talk about the rest of the modules. So to get started here in module 4, questions 1 through 11 in your packet, um, on number 1 it asks to find critical z values. And on the final exam, you'll have a question similar like this. And this one gives you just 4 different versions or percentages of confidence levels. So for this type of question, you want to refer to your formula chart. On the exam, you'll be given this formula chart. It's the same one that's stapled in your packet. And on the page that has the Z chart, on the positive side, there's these other 2 charts down here. And this is the one we're referring to for number 1 on the review. You see these percentages for confidence levels, and then there's corresponding Z critical values. So your answer to those questions are going to be each of those, uh, respective with the percentage that's given in the problem. So for A, for example, it says 80% confidence interval. You look at the 80% on this table here from that formula chart, and then your corresponding critical value is right there, 1.28. So similar for parts B, C, and D. So for this one, I'm just going to label them over here. So for example, part A is 80%. So there's part A, or rather, this value is the answer to part A. B is 90%, so there's B. C is 95%, so there's C, and then D is 99%. These are just examples, though, however. The final exam might ask you any of these percentages. You just have to find the corresponding value for those. So there's number 1, finding the Z critical value. Looking at number 2 now, it says, assuming all else is equal, what is the key impact the confidence level has on the width of a confidence interval? And that refers back to this table over here as well. Basically, what this is asking is, as the confidence level changes, what's the impact on the confidence interval? And as these values increase, for example, as the level of confidence increases, going down that chart, what happens to these numbers over here? They also increase. So you notice 70% going all the way to 99%. And then you see the Z critical values start at 1.04, and then they increase as we go down the list as well. So as your confidence level increases, so does your Z critical value. And so that Z critical value means that the width is going to get larger. So to give you a picture, you've seen this before. Here's your bell curve. And basically what's happening is, as we increase our confidence level, we are moving further out and widening the width of the confidence interval. So the confidence interval is the space between these 2 dash marks that I've made. Now those 2 dash marks depend on these percentages over here. So if we wanted to cover 70% of the graph, in the middle of it, it would be a certain distance between those 2 marks. And if we wanted to cover, like, for example, a 99%, we would have to move even further out from 70% because the total of this is 100%, right? So as I cover more space from left to right, our width is increasing. So for this one, we can say something like, as the confidence level increases, I'll just use an arrow to keep it simple. As the confidence level increases, the confidence interval also increases. So both of them increase. Let's move on to number 3. Number 3 says, which of the following impact the margin of error? of the confidence interval about the mean, and it gives you a list. So it's asking which of these items in the list. So we've got a few different items. We got the sample mean, the sample size, confidence level, standard deviation, median, and mode. It's asking out of those 6 values, which one impacts the margin of error. Now, the margin of error is part of this formula right here. It's this part after the plus minus. You use this to do a confidence interval, but the margin of error is just the second piece right here. And so what impacts this formula is each of these 3 items right here. So out of all of those, let's name each one of those. So that Z with a little c, that's your Z critical value, Z critical, and it's dependent on the level of confidence. Then you've got this symbol up here, which is a lowercase sigma. That is your population standard deviation. And we have this value right here, lowercase n. That's your sample size. So these 3 impact the margin of error. So to answer this question, I'm just going to highlight the ones that would be part of the answer to this question. So the sample, oh, I also forgot to mention the sample mean is right there, X bar. So I'm not going to highlight that. We only want these 3 right here. The sample size, which was n, the confidence level, which was determining what Z critical is, and then the standard deviation. So there's those 3 right there. These 3 impact the margin of error. The other 3, the sample mean, which is X bar, the median, which is none of these, and the mode, which is also none of these, do not. So I'm going to mark those out. There you go. All right, for numbers 4 through 7, these are examples where we're going to calculate the confidence interval. And as you can see, I've included the formulas next to each of these questions. However, on the final exam, the formulas won't be next to the question. You'll have them in your formula chart, but you'll need to know when to use a particular formula based on the question. And I'll show you different details to look for to know which formula to use. So let's do number 4 together. Number 4 says compute a 90% confidence interval for the proportion of heads observed if we flip a coin 100 times and observe 65 heads show up. So in this question, few things to identify first off is the words confidence interval, and it says for the proportion. And as you can see in this formula, I've taken this screenshot from the formula chart itself, confidence interval, and it says Z distribution proportion, right? Confidence interval for the proportion. So you want to match those up. This is how you know that you're going to be using this formula. And then before I actually work that problem out, I want to show you number 5 as well. It's worded a little differently. The information and the values are given differently, but you'll notice that it also says right here, compute the 95% confidence interval for the proportion. So you see those words right there, and those correspond with what you see there, proportion. Number 6 and 7 are the same minus 1 detail. These two say confidence interval for the mean. Confidence interval for the mean. And so as you can see, let me use a different color for those. Confidence interval for the mean, and there's the word mean. Confidence interval for the mean, and there's the mean. So as you can see, all 4 of these are confidence intervals, but the first 2 are proportions because they say the word proportion in the problem. The second 2 are for a mean because they say mean in the problem. So what I'm going to do is I'm going to work out number 4 and number 6, and then on your own, you should practice 5 and 7 just to make sure that you're able to confidently do those. And then you can compare with the key to check if your answer is right. So I'm going to work out 4 and 6 together here on the video. So for number 4, we have a few different numbers. We've got a 90% confidence interval. We flip the coin 100 times, and we see that there are 65 heads. And in this formula, you see there's various values. And so I'm going to show you how to determine each of them and how to plug them into your formula. So to start off, I'm just going to rewrite the formula. The little symbol above the P is a little hat. It's like a P hat. It's called P hat. And I'll explain what that means or how to determine the value for that. So P hat plus or minus Z critical multiplied by P hat times Q hat divided by N. So what I'm going to do over here on the right side is I'm going to list out each of those. We've got P hat, we've got Z critical, and notice how P hat shows up again. So I'm not going to rewrite it. It's going to be the same value for both of those. Then we've got, let me rewrite the order of those. Q hat first, because P hat and Q hat go together. Then I'll put Z critical, and then we'll put N. So these 4 values, you need to figure out what they are, and you can determine them from the information right here. So the first one I'll address is this 90% right here. This might be different from problem to problem. So for example, you'll see number 5 says 95%. 6 and 7 might have different percentages. That 90% corresponds with what we talked about up here. You want to find the Z critical value based on that percentage. So we see 90%, there's 1.645. That's the value for Z critical in this problem. 1.645. And I got that from the formula chart. And I'll just put a parentheses, 90% confidence interval right there. Now let's talk about N. N is really easy to find as well. It's the total number of trials in the problem. So in this case, it's a total number of 100 times the coin was flipped. So N is 100. And then P hat is the percentage or the proportion we're interested in. We're interested in the number of heads that showed up. And so since this was 65 heads that showed up, we would need to determine P hat by determining the proportion out of 100. 65 out of 100 is 0.65. That's P hat. Q hat is the proportion that was everything other than P. So if this was 65 out of 100, the remaining amount would be the number of tails. So 35 out of 100. This would be 0.35. And a good way to check this is that both of these together should combine to equal 100% or a value of 1. And now the rest of this is just plugging it in. So to set it up, I'm first going to write it out so you see how it should be set up appropriately. We've got 0.65 is P hat, so there's that value, plus or minus Z critical, which is 1.645. multiplied by the square root of P times Q, so 0.65 multiplied by 0.35, all divided by 100. And now, so I'm not going to spend time on this video going over how to punch this into a calculator because you'll be using the calculator you're comfortable with or the one that's on Canvas, but regardless of that, you want to make sure that whatever calculator that you're using, whatever scientific calculator that you're using, that you arrive to 2 values as your answer. Remember that there's a plus and a minus right there. You want to punch in all of these values into the formula with a minus first to get the lower level, or the lower bound, and then put a plus sign for the upper bound. So if you have questions about that, you can email me separately about how to actually calculate this using the calculator and punch this in you'll have to break it apart into steps. So you might want to calculate this fraction first, then take the square root of it, multiply by the 1.645, and then add and subtract from the 0.65. So when you do that, the answer that you should arrive to, rounded to 3 decimal places, 0.572 should be the lower, and the upper value should be 0.728, rounded to 3 decimal places. Now on the final exam, you'll have answer choices, so you'll be able to see how many decimals to round it to, so you don't have to worry about how to round it, because you'll be able to see all 4 answer choices and what they look like, so you'll know how many decimals to go up to. Okay, so practice number 5 as well on your own. Same idea as number 4. Let's do number 6. This one is a confidence interval about the mean. It says that a popular breakfast company fills their cereal bags with an average of 80 ounces. So that's important. And it also says a standard deviation of 7 ounces. So I'm going to start to write these values down as we go through the problem. So that first number is when it says an average, um, that has to do with either the population average or the sample average. So we'll want to kind of make sure that we navigate through the problem um, based off of what's in this formula right here. So listing all of those out, X bar, Z critical, standard deviation, and N, we'll need to make sure that we identify those 4 accurately. We get an average of 80 ounces, a standard deviation of 7 ounces. The sample is 36 bags. And we also have another average right here. Average of weight of those cereal bags to be 77 ounces. Compute the 95% confidence interval. So in the problem, there was 2 averages. There was an average of 80 ounces and there is an average of 77 ounces. Now, only one of them is X bar. The other one is mu. So the first one that it told us was mu because it's talking about the entire breakfast company in general. That is considered to be mu, so we don't want to use that. We don't need that in this problem, actually. We will use the 77 because that is the average of those bags referring to those 36 bags, which are sample size. So I'll put n as 36. The standard deviation is 7, just like it says there. And then to find z critical, we're going to go to our formula chart and find that table we talked about at the top of this page, 95%. So there's 95%. Our critical value, z critical, is 1.96. So now all we need to do is plug these 4 values into our formula right here. So setting that up correctly, we should have the setup look like this: 77 plus or minus z critical is 1.96 multiplied by the square root of 7, oops, not square root, sorry, multiplied by 7 divided by the square root of 36, just like that. So in this one, only the square root goes over to 36. The 7 is just on top of this fraction, and that fraction gets multiplied by the 1.96, which then gets added or subtracted from the 77. And if we punch this into our calculator, the 2 values you should arrive at are, rounded to 3 decimal places, 74.713 and 79.287. So what you can do right here is pause the video and make sure that whatever calculator you're practicing with, that you can punch this in and successfully get these 2 values right here. And if you have any questions about how to type it into the calculator, send me an email. Let me know if you have questions about that. I can walk you through the steps of how to type it in, or stop by before or after class and ask me how you would type this in, and I can show you That way you can successfully do that on a different problem. So I did 4 and 6. You should practice this for 5 and 7 as well, the same way we did 4 and 6. Let's keep going. We have a few more problems left in Module 4. On the next page, we've got questions 8 and 9. These are questions where you're being asked about the margin of error. So I'm going to work out number 8 here as an example. On number 8, it says, if we want to have a 95% confidence interval about the mean, and to have a margin of error of 5, what will be the minimum sample size required if the population standard deviation is 10? So the key phrase that tells you which formula to use is that phrase right there. Again, just like the previous problem, it says confidence interval about the mean. This is that formula. And listing out all 4 of these, I'm going to fill in what values are given to us. X bar, Z critical, standard deviation, and N. So just walking through all the values in the problem, we want to piece this together and see what we have and what we are missing. First, it tells us a 95% confidence interval. And looking back at our table, 95% goes with 1.96. So I can fill that in for Z critical. 1.96. We also have 10 as the standard deviation. So there's 10. And it looks like we have this number right here, margin of error of 5. Now this is a little bit different than the previous problems. The margin of error is just this piece of the formula here. So we don't really need to determine anything, or we don't really need to know anything about X bar in this situation, because we're only dealing with these 3 values right here. And so the problem doesn't give us a sample size. It asks us what will be the minimum sample size. So this is what we're being asked to determine. And the number 5 has to do with the value of the entire answer, the margin of error. The margin of error sometimes is referred to as capital E for error. And so in this case, it's telling us the error is 5. So the way I'm going to write this is I'm going to write error equals Z critical times standard deviation divided by the square root of n. All I did was I rewrote the formula using just the second part of the formula, not including the plus minus or the X bar. All of that is equal to the error. So now what I'm going to do is I'm going to take these items and place them where they need to go. So the error here would be 5 instead of E, because it tells us the margin of error, they want it to be a 5. 1.96, 10 divided by square root of n. So for this problem right here, we want to figure out what value we need for n. And to do this, we need to apply some rules of algebra. And when we do algebra, we're trying to solve for a variable. So we want to get n by itself. When we get n by itself, we need to apply, the opposite operation of what we see. So right now we have n all the way here, but we want to remove these other items and either divide them, add them, subtract them, whatever operations we need to do to get rid of these 2 values here. So when I apply those operations, if this is multiplication, I divide on both sides. So when I divide on both sides, I would do 5 divided by 1.96. And I'll divide here by 1.96. and that will cancel those two out. Then over here, 5 divided by 1.96 is 2.55. And I'm going to go to about the 5th decimal place, 2.55102. And that is equal to 10 divided by the square root of n. And then the next step is kind of a shortcut method, but what you can do is if you have your variable in the bottom of a fraction, you can swap these two values right here. Swap meaning you just change their position. So square root of n equals 10 divided by 2.55102. So let's figure out what this is right here. Ten divided by, and I'm actually just going to take this whole decimal and copy it. We get 3.92. We have a lot of zeros, so I'm just going to take 3.92. We have square root of n equals 3.92, and we're almost done. We want to just get the value of n here. The opposite of square root is to square both values. So we're going to square both values. And when we do that, we would get n equals, or I'm just going to continue this and put equals right here. So 3.92 squared, 3.92 squared, 15.3664. And there's that. Okay, so for number 8, these are the steps that you would take to determine the minimum sample size required. So what's the sample size that you would need is a 15. Now on the final exam, you're going to only have whole numbers as your answers. And so for this type of a question, let me erase that. Even though it's a 15.3, since it's talking about sample sizes, we're going to want to round this to the nearest whole number above 15. So in this case, 16. So I'm just going to say to round above it. That's only applied for this type of a problem. Okay. So numbers 9 and 10 involve the same process as number 8. So you can practice 9 and 10 the same way we did number 8. See if you can arrive to your answer. And then for the final one, number 11, the final question in this section, what does a confidence interval tell us? And what does a confidence interval not tell us? For this one, it is a definition. And the definition, you can look at it exactly word for word in the answer key towards the back. And you'll notice that the definition is right here on number 11. So take a look and read through this. And I'm not going to spend too much time talking about it here. But if you do have questions about it, of course, reach out to me or let me know during office hours if you have questions about what it means. So I'm going to pause the video right here. And in the next video, we're going to talk about Module 5, which is questions 12 through 20 in the next video.